Yes, different wire sizes can be used for different segments of a feeder, and this is known as conductor tapering. To size the wire at each segment, follow these steps. Firstly, calculate the voltage drop for each segment. Use an online voltage drop calculator or the following formula: voltage drop equals length of segment multiplied by current multiplied by resistance per unit length. Secondly, subtract the voltage drop from the source voltage. This gives the voltage available at the beginning of the next segment. Thirdly, select a wire size that meets the voltage drop requirement. The allowable voltage drop is typically 3 to 5%. Fourthly, repeat steps 1 through 3 for each segment. Here's an example using the values provided. Assume a load current of 200 amps and assume a resistance per unit length of 0.5 ohms per 1000 feet for 1250 kcmil conductors. For segment 1, the first 250 feet, the voltage drop equals 250 feet multiplied by 200 amps multiplied by 0.5 ohms per 1000 feet, which equals 0.25 volts. Voltage available equals 240 volts minus 0.25 volts, which equals 239.75 volts. For segment 2, the second 250 feet, assuming a 900 kcmil conductor with a resistance per unit length of 0.7 ohms per 1000 feet, the voltage drop equals 250 feet multiplied by 200 amps multiplied by 0.7 ohms per 1000 feet, which equals 0.35 volts. Voltage available equals 239.75 volts minus 0.35 volts, which equals 239.4 volts. For segment 3, the third 250 feet, assuming a 750 kcmil conductor with a resistance per unit length of 0.9 ohms per 1000 feet, the voltage drop equals 250 feet multiplied by 200 amps multiplied by 0.9 ohms per 1000 feet, which equals 0.45 volts. Voltage available equals 239.4 volts minus 0.45 volts, which equals 238.95 volts, and so on. The two examples are similar in principle, but there are key differences between a distribution system and a feeder with tapered conductors. In a distribution system, the loads are tapped off at various points along the feeder, so the current decreases as you move further from the source. This allows for smaller wire sizes as you go downstream. In a feeder with tapered conductors, the current remains constant throughout the feeder, but the voltage drop increases as you move further from the source. To compensate for this, the wire size is gradually reduced or tapered to maintain a relatively constant voltage level.